Hello, Assalamu alaikum dear student. I hope you are fine and doing well. Today I just come up with another series of my lecture. It's based upon once again classical crypto system we are discussing from last lecture. I had discussed shift cipher and affine cipher on just from set to set. So today's lecture is about how you can take any input of plain text as a block. It means as a polygraphic cipher. I am discussing polygraphic cipher, and in polygraphic cipher I will discuss Hill cipher, which is again based on what you call the matrix algebra. If I can generalize the shift cipher, I have a shift cipher which we have discussed, shift cipher or serial cipher, which we have discussed that encryption function was from Zn to Zn, and it is encryption x plus k, and the decryption function is from Zn to Zn, and I take it as a mod n, and then a decryption take output, or this I call it as a y, that is the y minus k of mod n. So default decryption. So you can see this one, this is some set to set, and if I recall this I'm generalizing this over matrix algebra. So what I have to do is to just start my generalization if I shift cipher our matrices. So what does it mean? So here encryption function is from Z n to say S to Z S n. So I can say from n. So in that case, x minus plus k mod of s. So if you can see, these x and k are belonging from D set. That is, x is belonging from Z S n, and k is also belongs to Z S n. It is n tuple whose element are from Z S. If I can say decryption function Z S n to Z S n. So decryption is, you know what, I call it this as a y, the output of this is y dash. So I am discussing everything as a tuple, vector. So I call, just place dash over this y. So y dash k, and what you will get, your plain text. So again I am generalizing the idea that is was from set to set, or this is from tuple to tuple. So the shift cipher or matrices, you can generalize in a quite easiest way. If I can let me do some example, I have lastly what I have Ali. So I take it as a input, and I suppose Ali Li as a 3 cross 1 column vector. So you can see the encryption function over here is Z26 3 to Z26 3. So my x is 3 cross 1 column vector, and was individual entries is, this was 0, and this L was 11, 11, and I was 8. I was a map on 8.
Yes, 8.
8. So So this was 3 class 1 column vector, and this is belongs to from Z26 3. So I mean to say individual element are from Z26 and it can be written as a 3 class. So I put 3. So encryption, I take key as 1, 2, 3 as a key. If I encrypt this LE by using generalization of shift, cipher or matrices, so I have to use X plus K. So I just put this X input, so which is 0, 11, 8. Sorry. 0, 11 and 8, and then I just plug 0, 11, 8 and just add my key, which is, you can see 1, 2, 3. So what you will get? 1 and 13 and 11. You can see this is B and this one is 11, 13 is map over N.
N, yes sir.
N, and this is again L. So you transform Ali into B and L. Now you are transforming your shift cipher into matrix algebra. So this is one of the application. So the decryption is left as an exercise. You have to do it by yourself. So let me generalize a Affine cipher first. If you see from my previous lecture, Affine cipher was like encryption was ax plus b mod of n, and encryption function from Zn to Zn, and decryption function was like from Zn to Zn, and d of x, I should not put x bar over here because this is a from set to set. So it is A inverse y minus b mod of n. And the condition GCD of A with n must be 1 and b is any what? Any element from Z. So if you can see this one thing that is why I'm going to do is, which is if I just use the this stretching, or I can say thing or linear cipher, that is encryption from Zn to Zn, and I call it as A into X mod of n. Not adding b, just take A to X. I call it as a stretching only. You just multiply A with X, and A is a stretching parameter. And decryption is A inverse of y mod of n. So you can see here GCD of A with n must be 1. In that case, A1. So if I can generalize the first case, which is this case is the generalization of this case, because this is the simplest and this is more complex, affine. So if I generalize this, what you call Hill cipher. So Hill cipher is nothing, it is just the generalization of this stretching or linear cipher, our matrix algebra. So let me define Hill cipher. Let A belongs to any n plus n matrix matrix of our Zn, its determinant must be non-zero. This is M cross N matrices. You can take a matrix as non-singular matrix, or I can say that A belongs to this one, or I can say, sorry, let me correct this one. General linear group of order n over Z M. ठीक है, और जनरल लीनियर ग्रुप में which type of elements are fall in general linear groups was determinant is non-zero. So I have to what you call take any matrix, but its determinant must be GCD of its determinant must be 1. Let me elaborate this one. If let us consider a matrix A belongs to, let me generalize this one, and with encryption function E, that is E is a function from Z M to N. Okay, so E of X A into X mod of इंक्रिप्शन फंक्शन एक n क्रॉस n का मैट्रिक्स है जिसकी एंट्रीज कहाँ से आ रही है Gm में से, ठीक है। और ये सिर्फ आपने वहाँ पर हमने क्या किया था, a कोई एलिमेंट लिया था इसमें से। अब चूंकि ये n से n पर जा रहा है तो यहाँ पर क्या आएगा, मैट्रिक्स आएगा, क्योंकि टपल टू टपल ट्रांसफॉर्मेशन है। अब एलिमेंट नहीं आएगा बल्कि मैट्रिक्स है। तो इसके ऊपर भी तो कुछ कंडीशंस होनी चाहिए ना, ए के ऊपर जिस तरह उधर कंडीशन थी। अब दिस इज मैट्रिक्स, हाउ यू कैन जनरेट नंबर फ्रॉम ए मैट्रिक्स? ओके, सो द वे इज टू टेक इज डिटरमिनेंट। सो I have to take, I am not taking any matrix, I just take the matrix over here, वो GCD, वो determinant GCD with n must be 1. Encryption function of A into X with, you can write it over here, with GCD with the condition, sorry, with the condition GCD of determinant of A with n is 1. So in that case you can not only encrypt but also decipher. If you don't put this condition, this one like this one, so you only encrypt but you cannot decrypt your plain text, cipher text. So let me, this is just the generalization of this cipher over here, and this is one of the polygraphic cipher. So here you can take every element as a whole tuple instead of a single element, instead of dealing as a mono plain text, individual element, you have to take as a full tuple and manipulate the calculate it with the help of this one. So if you can see this one, decryption is again ZMN to ZMN, and for decryption A inverse of Y dash mod of N. So if you can see, this is a whole complete crypto system because it has 5 tuples. One is encryption, plain text, set of plain text. What is set of plain text over here? Space of plain text, ZMN, and set of cipher text, ZMN, and encryption function is this one, and decryption function is this one, and key is your matrix A, and I call it as A. Key is matrix A. So this is 5 tuple. As I told you, the crypto system is in a simple way 5 tuple. So here your cipher space of plain text is this one, space of cipher text is this one, encryption is this one function, and decryption is this one, and A is your security key. So if I can generalize this to a affine cipher, what does it mean? It means encryption from ZMN to ZMN, and the encryption function over here is AX plus B mod of N. Here you can see there are two security keys, two what you call keys. One is A and second is B. So decryption function is from ZMN to ZMN, and D is decryption function. So if I can put this equal to Y, so how you can solve this equation for X? This will be A inverse Y minus B mod of N. So this is your decryption function. If you can recall your simplest Hills affine cipher, so there was just inverse of an element, but there is an inverse of matrix. So if you can look over here, one more thing that if you can see this one, the Hill cipher, linearity. If you can see if T is a transformation from ZMN to ZMN, then it will be linear, that if we satisfy this property Y, and this is alpha time X plus beta time, if these are equal. And if I say this one for in case of Hill cipher, in case of, if you can see Hill cipher, T is like A into X, so T of X is
basement की बस वाला सागर yok da bak tasın öyle
तो
लक्ष्य पास करे सर पास करे oh
so I told you about the linearity property will be satisfied by Hill cipher, but the affine Hill cipher, which is like this one, this does not qualify the property of linearity. That I mean to say T of X and Y. In case of this one, X plus y plus b, and this is ax plus ay plus b, and this is ax plus b and plus a of y, and this is equivalent to t of x, but there the b is missing, so in that case we cannot say this is equivalent to this one. So this is one of the very good characteristics of what you call the that must be exist in modern block cipher, that it must be non-linear, that it has to satisfy the non-linearity property. As I told you while discussing the multi-valued Boolean function, that it should not be uh, linear, it must satisfy the non-linearity property. So the affine Hill cipher qualify for this characteristics, but linear property is satisfied in case of Hill cipher. So let me elaborate this Hill cipher with the help of one example, and that's end up with my today lecture. So let me elaborate this with so if you can see example. So how I can select this matrix A? If you can see this one, the determinant is 3.
Yes.
So determinant is 3 and the GCD of determinant of with 26 is 1. So if you can take all such possibilities by your own. So you have to have, so in that case encryption function is from Z26 to Z26 2. I just give you this information. It means to say my matrix from if I don't put this transformation in, even then from this 2 by 2 matrix you can just see this transformation will be from the 26 2 to 2. If the matrix is 3 by 3, so the tuple will be from 3 to 3. Okay, so solution. The encryption function in Hill cipher is Z26 to Z26 and it is A into X mod of 26. So I take from 2 to 2, so I have to break my plain text into 2 class 1 column vector, that is H, E, A, D. This is my x1 is H and E, and my x2 is A and D. So from here, if you can see over here, H is map on 5 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So this is 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So I just use this mapping, this table every time, so I have to put over here. So H is map on 7 and E is map on 4. Then X2, A is map on 3 and D is map on 3. So I have to use this A into X. So A into X is my, what you call the encryption of first tuple, and that is message is 5211 and into x1. X1 is 7 and 4, and this will be 35 plus 8, and then 7 plus 4. This will be what is 43, and this is 11. And if you can take mod under mod 26, what you will get 17.
Yes, sir.
This is 17 and 11. So 17 is correspond to R and 11 is correspond to L. So if I can take x2, that is 5 1 2 1, that, and then 0 3, that you will get 5 6, then 3. So this will be 6 is map on G and 3 is map on D. So ultimately, if you can say this one HEAD, if you pass it through E, you will get R L G D. This is your what you call encrypted message, encrypted, and this is plain text. So I have to apply decryption in order to get back my original plain text. So what I have to do is to, and I call it, these are the y2 and this is the y1. So I have to take for decryption function. So I have to find inverse under mod 26. So inverse of A is what you call adjoint of A divided by its determinant. So determinant is 1 over 3 and adjoint is what you call 1 5 minus 1 and minus 2. So here 1 over the inverse of 3 is 9. So this will be 1 5 and you have to have add 26 because there is a minus. So under mod 26 0 or under mod 26 is additive identity. It has no effect over your calculation. So you have to have add over in minus values in order to get back these values into Z26 in order to satisfy the law of closure. So you will get 24 and this is 25. So if you can see this one, how you can get back these. So
2 minutes. 2 minutes.
okay, d of y1, and this was 9 1 5 25 and 24. You have to multiply it with R 17 and L 11. So in that case you will get 7 and then 5. Sorry, 4. And then you will apply on x2 9 125, 24, 5, and then G 6 and he is 3. So in that case you will get 0 and 3. If you can see this one, we will get back like if I apply like D to these R and GD, I will get back HEAD. So, dear student, I just give you the example of Hill Cipher, which is one of the polygraphic substitution cipher. It takes as a tuple, as a packet, as a block of individual what you call the plain text, not discuss this as a individually as in our earlier shift and affine cipher. But and for you, you have to have solved this example with the help of affine Hill cipher. And for as a homework, you have do to find how many such matrices you can calculate in affine as well as Hill cipher as well as affine Hill cipher. Till then, Allah Hafiz. May Allah bless you all.